decomposition method is used for seasonality. So we're looking at this data, which we have 24 time periods, 6 years of data separated by quarters. So 4 quarters per year for 6 years is 24 time periods. First thing I'm going to do, like always, is build a scatter plot, plot my time, plot my demand or volume over time. And you see we have 2 components. We have a seasonal component. We have a bump every 3rd quarter, as well as a trend, even if we didn't have any seasonality in quarter 3. So once we've got this, the first step is to determine what our seasonal indices are. And I start calculating something called a seasonal ratio. The seasonal ratio is equal to the call volume, or the demand, divided by the average of everything that I have. So my overall average for a time period, and notice what I'm doing, I'm putting some dollar signs around this, so when I copy it down, the references are fixed. And I do that for all of these, so I have all of these seasonal ratios. And then I can calculate my seasonal indices or seasonal indexes. For quarter 1, how many of these do I have? I've got this one and this one, and I'm holding the control key down to grab these data that's not contiguous. 1, 2, 3, 4, I have 6 of them. And I can copy that down for the next 3 to get for every time period. So those are my seasonal indices. I only need 4 because I have 4 quarters. So if I ask you what is the seasonal index for quarter 3, you would say 1.16. The interpretation of that is that quarter 3 is 16% higher than a straight average. These need to repeat. So I'm going to just go reference 4 rows above it, and then for every one of these, if I just pick one, you can see it's always referencing 4 rows above it. That's how we can get these to repeat. I'm going to predict the future, so I'm going to go out another year and then continue these, working their way down. So now that I've got the seasonal indices, the first step of the decomposition method is to deseasonalize. And how you do that, you divide by the seasonal index. You deseasonalize by dividing, so I'm going to take the actual and divide by my seasonal index. And it's going to take the valleys and move them up, and it's going to take the peaks and flatten them out. And if you just want to see what that looks like, there you go. I guess I could have been better to draw a line. But there. So you can see the red is the deseasonalized data. And it's taken the spikes and moved them flatter, and taking the valleys and moved them up. So it's an attempt of removing seasonality. We still have a trend. So now I'm going to forecast. Now that I have that, now that I have this, then I'm going to take my deseasonalized, which are the red, and I'm going to add a trend line to get the equation. So this is the equation. So the step 2 now is to forecast the deseasonalized actuals. And you can use any forecasting method you want. You can use exponential smoothing, trend adjusted. For the class, what I want you to be able to do is be able to use the trend, because it's a clear trend. So if I'm going to forecast the future, I'm going to start here, and it's going to be equal to my 17.558 times my time period, which is this, plus my intercept, plus 329.23. And that is the end of the future without a seasonality. And again, if I wanted to just show what that looks like, it would look something like that. No, that's not what I wanted. There you go. And there you go. That's without any seasonality. So the last step of the decomposition method is to add my seasonality back. Add seasonality by multiplying by the seasonal index. So this is going to be equal to my forecast without seasonality multiplied by my index. And then that's what I'm going to forecast. This is by time period. Here is the actuals, and then this is my forecast with seasonality. If I showed what that looked like, there you go. And so there's the predicting it. So that's decomposition method. Calculate the seasonal indices, divide, deseasonalize, forecast some way, and then add seasonality back. That's what decomposition method means. Thank you.